Okay, so for example number 1, you're writing everything that I'm writing. So example number 1, we're going to do this compound right here. First, I want you guys to tell me what the name is of it. Talk to your table real quick about what the name is going to be. So practice that.
Wait, no, not perchlorate.
Anybody want to take a shot at it?
Nope.
Damien, what you got? Okay, this one is carbon tetrachloride. Okay, we don't put mono on the front because even though there's only one of them, because we never put mono on the first word, so it's carbon tetrachloride. Tetra means 4. And let's talk about, we're going to follow along with your instructions. You're going to tell me what to do. So what does it tell us first to do on the list of instructions? Add up the total number of valence electrons. So let's look at each one of them. Carbon has how many valence electrons? 4. Okay. And chlorine has 7, and I've got 4 of them in here. So 7 times 4 equals 28. So I add those together and I have a total of 32 electrons. Every time you're doing these, you're going to have on the side, you're going to do a little tally of math to keep yourself honest about how many electrons you're working with. Okay, what's the next step say to do? Divide that number by 2. So I have 16 pairs of electrons to work with. Okay, next step. What does it say about the single atom? Place a single atom in the middle. In this case, what's our single atom here? Carbon. So carbon's going to go in the middle. And then I'm going to draw a line to all the terminal atoms. They're called terminal atoms because it's like if you've ever been to an airport, you walk down these really long hallways. They're called jetways. They're really long like hallways. And at the very end of the hallway, you get to a little place where all the planes are parked out here. And same thing here. So this is terminal A, this is terminal B, and so on. So we call these terminal atoms out here. So what does the next step say to do? We place the terminal atom. So what does it say to do?
Draw a line.
We drew the line. What next?
Subtract the number of bonded pairs.
Subtract the number of bonded pairs from the total number of electron pairs that we had. So we used how many bonded pairs? 4. And let's mark that in our notes so we know that those are bonded pairs. We don't forget, because like I said, 10 p.m.U. is not going to be the same as you are right now. So this is a bonded pair of electrons. The line represents a bonded pair of electrons. Okay, so I've used 1, 2, 3, 4. So I'm going to subtract 4 from my total. I have 12 pairs left to work with. Now what does it say to do? Place the remaining pairs around the terminal atoms. Now, how many electrons or valence electrons does every element want to have, or most every element? 8, okay? We must satisfy the octet rule. So this line represents 2 electrons. Okay, so I already have 2 for this chlorine. So how many more does it need total? It needs 6 or 3 pairs. Would you agree? Yeah. And I'm going to draw them as pairs because I'm a civilized person. Okay, I'm not going to draw hot garbage. It's messy. Whoever's grading it can't read it. And when you look, you added 3, 6, 9, 12 pairs around the terminal atoms. So you have no pairs left. Okay? So every chlorine feels 1, 2, 3, 4 pairs. 1, 2, 3, 4 pairs. 1, 2, 3, 4. 1, 2, 3, 4. Every chlorine feels like it has 8 electrons around it. What about this carbon in the middle? It has 2, 4, 6, 8, or 4 pairs around it, so it's satisfied. Everybody's happy here. We say happy. We know they're not really happy. They don't have feelings, but they're satisfied. We don't know that. You're right. Okay? So, something I want us to get used to here is identifying how many bonded pairs and how many lone pairs you have. Bonded pairs are the lines. Lone pairs would be pairs that are located on the central atom that are not bonded, meaning like if we had dots on the central atom. So how many bonded pairs do we have here? Okay, so this drawing has 4 bonded pairs, and it has no lone pairs. So a lone pair, and you'll see in a minute when we draw another one, a lone pair would be dots on the central atom. But we don't have any dots on the central atom, so we have no lone pairs.
Wait, carbon's the central atom, right?
Yes. It's in the middle.
Why would you have dots?
You're going to see in just a hot
That makes
minute.
it where someone's sad.
Why would they be sad? No?
Because you got...
Okay, number 2. Next one we're going to do is going to be PF3. What's the name of PF3? Phosphorus trifluoride. Phosphorus trifluoride. Okay, let's start with the first step we always do is we're going to add up the number of valence electrons we have. So phosphorus has how many? 5. 5. Okay. Fluorine has 7 times 3 is 21. So 26 electrons. Okay, now I'm going to divide by 2 so I can figure out how many pairs I have. I have 13 pairs to work with. You have to do the small accounting over here off to the side. You have to. If you don't, you're going to just draw things that you don't even necessarily have the right number of electrons to draw. Okay? So you can't skip it and be like, oh, I got this. I know what I'm doing. That's not how that works. So who's going to be the central atom?
Phosphorus.
Phosphorus will be. Okay. We learned last unit that these guys want to get as far away from each other as possible. So what kind of configuration should I put the fluorines in?
A triangle.
A triangle. So I'm going to put a fluorine here, and one here, and one here, and draw a line to each one. And the line represents a what?
Bonded.
Bonded pair. Okay, so I have now used 3 pairs. I've used 3, so I have 10 left. So we're going to put our pairs around the terminal atoms. So that's 3, 6, 9. And I have 1 left over. Okay? Where does it say to put the 1 left over? In the middle. Okay? Because look what? Phosphorus was not satisfied before we had that pair. Okay? Phosphorus had only had 3 pairs around it. That's the 4th pair.
So he is happy.
So he is happy. We made him happy with the lone pair. So how many bonded pairs are in our picture? Okay, so 3 bonded pairs. And 1 lone pair. We use 3, 6, 9 around the terminal atoms.
So there can't be more than 4 terminal atoms?
Oh, well, just wait. We got. This is why I love this unit. There's all kinds of cool things that get to happen with these. Okay?
Oh, that's not cool.
No, it's super cool. Okay, next, number 3. This one is going to be F2. And you know what its name is? Fluorine. Nope, it's fluorine. That is how fluorine is in its natural habitat. When fluorine is not already bonded with something else, it will always be bonded to one of its own. Yep, there's a whole set of elements that are like that.
Why?
Okay, I'll talk to you about that tomorrow. All right, so I have fluorine. What's the first step I need to do? Add up the valence electrons. I have fluorine has 7, and I've got 2 of them, so that's 14 electrons.
Well, you're just going to divide by...
Divide by 2. I have 7 pairs. And then I'm going to bond the 2 fluorines together. So there goes 1 pair. So I have 6 remaining. Make sure they all feel happy with their 8 electrons around them. Now, I'm going to tell you something. This seems easy when you're watching me do it. Okay? When you're going along, yeah, got it. It's like I tell everybody every year. It is like riding a bike. If you don't know how to ride a bike and you're like 7 years old and you go watch YouTube videos and you can see how people move the pedals, you can see how they do the steering wheel, and you're like, I got it. I watch these people ride a bike. I know how to ride a bike. But you all know from learning how to ride a bike, is that how that works? No. When you get on the bike, you have to balance the bike, and there's a whole lot more to it than you think. And so you have to do it yourself. So I'm going to do 5 with you today, but the learning doesn't really happen until y'all are on your own. Okay? So I want you to understand, I want you to feel comfortable doing it, but you're going to be uncomfortable when it becomes you on your own. And today is not the day to skip homework. Okay? Tomorrow we're adding on to this. So if you come in tomorrow and you're like, oh, I forgot we had to do that, and then you're clueless and you're like, oh my gosh, this is so hard because now we're doing this other stuff and it's so hard, I'm going to lose my patience because I told you guys this is super important today to get this done. Okay? Now, do we have any lone pairs or anything left over? No. And we're not going to put, on these, we don't do bonded pairs, lone pairs. When it's just what's called a diatomic element. It's just 2 of the same thing. We don't worry about that. Okay, let's do another one. Let's do number 4. We're going to do H2S. What do we call that? Monosulfide, right?
Right.
Monosulfide.
Wait, what is mono?
1. Right. So let's count up our valence electrons. Each hydrogen has how many? 1, and I have 2 of those guys, so I have 2 electrons from that. How many does sulfur have? 6. So that's a total of 8 electrons.
4 pairs.
Divide by 2, I have 4 pairs. Who's going to go in the middle? Sulfur. Okay. I got 2 hydrogens to attach, so I'm going to use those 2 pairs right there. Minus 2. I have 2 pairs remaining. Now, let me tell you something. Hydrogen never gets dots. Hydrogen cannot get dots. Why? It only has a 1s sublevel. It can only hold 2 electrons.
Oh.
Okay? Hydrogen can never. So write yourself a note right here, wherever it is. Hydrogen, and write it big. Can never have dots. Hydrogen can never have dots. Yes, but we don't do anything with helium. Okay.
Wait, so do the 2 pairs go around the S?
Okay, so where do we put leftover pairs that don't go on the outside?
Interesting.
They go on the central atom. Now your temptation is going to be to draw them above and below the S. And I love that for you, that you want the symmetry of that, but I'm going to break you the habit now because I'm going to teach you in a couple of days how we have to really amend these drawings. We're doing baby drawings today. We're doing intro to drawings, so they're just like our best effort. But in a couple of days, I'm going to teach you why we need to actually draw them a little bit more sophisticated. So I'm going to teach you to draw for these guys. They're going to have both their pairs are offset off the top. You don't have to understand why right now. And you can do top and bottom. Let's break it now.
But if you did that on the test, would it be?
Yes, because I'm going to teach you the correct way to do it. Yeah. We're going to do more of a 3-dimensional drawing. Okay, so how many bonded pairs and lone pairs are in this guy right here?
2.
So we have 2 bonded pairs and 2 lone pairs. That's why I have this guy. He's my lone pair. Get it? Y'all are so rude. My lone pair. Haters gonna hate. Okay. Usually my kids go, oh, now I get it. Y'all are like, okay, that's fine. Okay, last one. Number 5. PCl5. By the way, was everybody happy up here? 2, so it had its 2. Sulfur needs to have 8, so we have 2, 4, 6, 8. Everybody happy?
Yep.
Yep, everything's satisfied.
Is
All
it
right.
possible for someone to be sad?
If they didn't, then we didn't draw it correctly.
Right, so everyone has to be happy.
Yes. And sometimes they can be extra happy. Draw this next one. Go.
Sometimes happy. 20 pairs?
Okay, this is what you should have. Do you agree with me?
Yes, I do.
Okay, that is the correct drawing. What's weird about it? So how many are around the central atom?
5.
Means it has 10 electrons around it.
Oh, yeah, that's what.
It's extra happy. Okay, so
Is that allowed?
it is allowed. When you are looking at your periodic table, anything that is period 3 or below can have what we call an expanded octet, and we'll talk more about it tomorrow. They can have an expanded octet. Why do you think period 3 or below? Talk to your table. See if you guys can come up with why they get to have more than periods 1 and 2.
That's what the European. Is that right?
Something.
Why do elements in period 3 and below get to have an expanded octet? Why do they get to have more than 8?
This one.
Why?
Like that,
What about that, CT?
the periods above that also had happy.
Okay. What do they have? What is phosphorus? What does period 3 have that isn't used? I guess I could say that. The third energy level has what in it? It has a D sublevel, doesn't it?
Yes.
The third energy level has D sublevel. So this is why that D sublevel allows group 3 and below, period 3 and below are allowed to make expanded octets. But there's none like that on your homework, so don't fret. So I'm going to give you your homework and get you guys started on that.
I'm finishing before class ends. Alright,